Hello and welcome to lesson 8D. I can find missing angles using an inverse trigonometric function. So we learned last lesson about trigonometric functions. Remember our big acronym was SOHCAHTOA, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then we learned last lesson about how we can use these functions to find missing sides of triangles. Well, now we're going to learn how to find missing angles if all we know are side lengths. Inverse trigonometric functions allow us to basically undo trig functions and help us find missing angles. The first thing we're going to look at is how to solve these in your calculator. So sine of g equals 0.5163. Well, if I want to find the measure of angle g, that's going to equal sine inverse of 0.5163. And so now when I hop into my calculator, we're still looking at our trig button, but now we're looking at our actual sine inverse function. And sine inverse function. And we're going to delete out a lot of those. Yay. Okay. Sine inverse of 0.5163. And that tells me that if I have a ratio of 0.5163, the angle measure is 31.1 degrees. So that means that the measure of angle G equals 31.1 degrees. So that's how we use trig functions. So now let's take a look at cosine. If I know that cosine of m equals 0.2894, then the measure of angle m is going to equal the cosine inverse of 0.2894. So we're going to hop into our calculator, and again we're going to look at our trig function, and we're going to click on the cosine inverse. Cosine inverse. Oh my gosh, I don't know what's going on. Cosine inverse, and I now forgot what number we're looking at. 0.2894. 0.2894. And we get 73.2 degrees. So that means that the measure of angle M equals 73.2 degrees. I want you guys now to pause and in your calculator, practice finding the inverses of these four functions. All right, guys, check your work. So now, as we are moving right along, we're now going to use these to set up and solve some equations to find missing angle values. So just like we did last time, our first step is always to identify the angle. My second step is to label my sides. Third step, identify, or I'm going to say choose. You're going to choose a trig value. Choose trig ratio. And then fourth, after we choose our trig ratio, we're going to set up an equation. And solve. Those are our steps. So let's take a look here at this first one. My angle right here is angle theta, which is at angle K. So that's my angle. Opposite of angle K is 12. Across from the right angle is the hypotenuse, which means that my leftover side is adjacent. Because they've given me the 12 and the 24, that's the O and the H. Well, when I think about SOHCAHTOA, I've got an O and an H, so I'm choosing sine. So I'm going to do sine of theta equals opposite 12 over hypotenuse 24. So that means that theta is equal to sine inverse of 12 over 24. So we now grab our calculator and we choose, I don't want a 3, anyway, sine inverse, deleting out that 3, of 12 divided by 24. By the way, guys, if I had reduced that fraction, sine inverse of 1 over 2, I get the same answer, right? So you can reduce the fraction. So that means that theta is actually equal to 30 degrees, which is really nice. So the measure of angle K is equal to 30 degrees. All right, let's do another problem. Here on 7, they've given me angle P, and now I'm going to label my sides. So this guy's my opposite, this guy's my hypotenuse, which leaves this one as the adjacent side. I now look and see which ones they gave me. I've got the hypotenuse, and I've got the adjacent side. Well, that's A and H. Cosine is the only one with A and H. So cosine of theta equals A over H. I'm going to plug in, I still don't know theta. Cosine of theta equals, my adjacent side is 6, my hypotenuse is 9. So theta equals cosine inverse of 6 over 9. So now we're going to plug into our calculator. We're going to go cosine inverse of 6 over 9. That's 48.2 degrees. So coming back here, that means theta equals 48, come on, right, 48.2 degrees. Okay, let's take a look at our next problem. Down here, our angle is this theta right here, Opposite of the theta is the 48. Across from the 90-degree angle, that's my hypotenuse, which means that the 14 here is my adjacent side. I'm now going to look and see what ratio to use. Well, they gave me a 48 and a 14. That's the O and the A. Well, O and the A is tangent. So I'm going to do tangent of theta equals opposite over adjacent, right? So tangent of theta, plugging in, the opposite was 48. The adjacent was 14. So theta should be tangent inverse of 48 over 14. We're going to jump to the calculator, and we're going to do just like we've been doing. Tangent inverse of 48 over 14 gets me 73.7 degrees. So theta equals 73.7 degrees. All right, let's take a look at number 9 now. Now, number 9, I'm looking at this. We always start off by identifying my angle. My angle is here. That's the theta. Opposite of theta is 42. Opposite of my 90-degree angle, that's my hypotenuse. That's 70, which leaves the 56 as the adjacent. Pause. They've given you all 3 sides, so you can choose which ratio you want to use. You have choices. So I could do sine of theta equals O over H, in which case I do that sine of theta equals O is 42, H is 70, so theta equals sine inverse of 42 over 70. Well, let's plug that in and see. So I'm going to go right here, sine inverse 42 over 70, which gets me 36.9. So theta equals 36.9 degrees. I could also change it up and look at a different angle. I could also solve this in cosine. What did it do? Forwards. Sorry, friends. Forwards again. Yeah, sorry, guys. You're getting to watch me versus the computer. Yay. Okay, we could also solve it with cosine. Well, cosine of theta is adjacent over hypotenuse, A over H. Well, cosine theta, the adjacent side was 56. The hypotenuse was 70. So theta would equal cosine inverse of 56 over 70. So when I come to my calculator, I'm going to use trig cosine inverse of, did I say 48 over 70? 56 over 70. Okay, 56 divided by 70. We get, again, 37 or 36.9 degrees. We're getting the same answer. So theta is, again, 36.9 degrees. Well, now let's look and see what happens if we use the tangent function. So I don't want red. I've already used red. Let's switch to something else. So tangent of theta is equal to opposite over adjacent. So tan of theta is equal to, well, your opposite side was 42. Your adjacent side was 56. So that means theta equals tangent inverse of 42 over 56. Well, we hop into the calculator. I'm going to go tan inverse of 42 over 56. And oh my gosh, we get the same answer. What a surprise. So theta definitely equals 36.9 degrees. So basically, if you have more than one option, it really doesn't matter which one you choose. You could use any of these. So all were valid here, right? They were all valid. And we all produce the same answer if you're doing it right. So anyway, that is how you find missing angles when you only know side lengths of right triangles. You use your inverse trigonometric functions. All right, guys, take a look at the MML and we'll see you in class.